right, let's continue with period. So what is period? Period, and this is all in your notes, so please fill in your notes, is the time it takes to complete a full cycle. Have a complete wavelength. And then at the end of the period, it starts over again and again and again and again. How is it calculated for the graphs of sine and cosine? If you have a graph, you're going to look where the pattern repeats. Right? And so we're going to find some periods from some graphs. All right, so here we're going to find the period of the graph. All right, so this one is pretty easy to find the period because we only have one period here. So it's pretty easy to find the length of that period. All right, and so if we look along the x-axis, we can see that it takes 5 seconds for the period to go through for the function to go through the cycle. So the period of this graph is 5 seconds. We're also going to write the equation for the graph. This is, we have one period of sine here, right? And so we need, this is going to be the format, y equals a sine bx. All right, and we need two things. We need a and we need b. We found a previously when we were finding the altitude, so that was on the previous lesson, but I will go over that. So the altitude for the graph is to find altitude, you take the highest value, the maximum, minus the minimum, and divide by 2. So the maximum is, myself a little more space. So the max is 0.6. The min is negative. Right, so here's the max. Here's the min. So the min is negative 0.6. So the amplitude is 0.6 minus negative 0.6 divided by 2. So that would be 1.2 divided by 2, which is 0.6. So that's the amplitude, that's A. We're going to solve for B to find the other part of our graph. And to find B, we're going to use, let's put that back in the right spot. We're going to need to use the period. So I'm just going to give myself just a tad more space. So if you remember on the previous video, we found, we learned that period is equal to 2 pi divided by b. We know the period for this graph, it's right up above, it's 5 seconds. So if we substitute 5 for period, we can cross multiply and solve for b, and then we can write the equation. So 5 is equal, so I'm going to put 5 over 1 actually, so that I've got, makes it easier to cross multiply. 5 over 1 equals 2 pi over b. We'll cross multiply. So we have 5b equals 2 pi. And then to solve for b, just divide by 5. So b is equal, put it over here I guess, b is equal to 2 pi over 5. And that means that our equation, so in our equation here, we're going to substitute the 0.6 for A, and we're going to substitute the 2 pi over 5 for B, and we have y equals 0.6 sine 2 pi over 5x, and we've written the equation of our graph. So that's really all the steps to writing the equation of a sine or cosine graph that has not been shifted right and left or up and down. This graph has not been shifted. It's starting at, it's a sine curve that's starting at 0 and starting at 0, 0. So that graph has not been shifted in any way. So all we have to do is solve for A by finding the amplitude and solve for B by using the period. And then we can replace A and B in the equation, and we have the equation for this graph. Right? That's all there is to it. So we're going to do a few more. There we go. All right, so, and actually any of these graphs could be written as sine or cosine. Anytime you have, so if this would be a period of cosine, and we'll learn how to do that later. That would be one period of cosine, but notice that's not starting on the y-axis. That graph has been shifted to the right. So you would have to learn how to write, you'd have to learn about phase shifts to be able to write this equation in as a cosine graph. But we can write this equation also as a sine graph. So any sine graph could be written as a cosine equation. Any graph of sine or cosine could be written as the equation of the other, because they essentially are the same graph, just shifted. All right, so, but we are going to stick to writing the easiest equation right now, and that would be easiest if we wrote the equation as a sine equation rather than a cosine equation. All right, so the first thing we need to do is figure out the amplitude. The maximum value is 1. The minimum is -1. So you probably have already figured out the amplitude, but we'll put this in our notes so that you have the steps. So the amplitude is going to be 1 minus a -1 divided by 2. So that's 2 divided by 2, which is just 1. And I think you probably saw that from the graph, right? That we have an amplitude of 1. And a lot of times you can just figure out amplitude from the graph, but it's really helpful when your graph has been shifted up to calculate it using max minus min. All right, and then we need to determine the period and solve for B. So the period, I'm going to do that right here, I think. The period, well, you can see it takes 2 pi to complete the cycle. I have that outlined in red. All right, so we can solve for B because period is 2 pi divided by B. So if our period is 2 pi, I bet you can figure out what B must be, but we'll go through the steps. You can go ahead and put this in your notes. So 2 pi B equals 2 pi. Well, if you divide both sides by 2 pi, B is 1. So if it takes your graph 2 pi to complete the cycle, then B is 1. All right, so now you'll know that for the future, but I did think it was important to solve it out so you can see, yes, that's why B would be 1. And so this is, and we have no amplitude change. We have no change in period. This is just y equals, so I'll actually write the formula. Y equals A sine bx for a graph with no translations. A is 1 and B is 1, so this is y equals sine x. This is just the basic sine curve. This was easy. But we went, so even if you weren't sure what the equation is, All you have to do is solve for the amplitude and use the period to solve for b, and it's really easy to write the equation because you just replace the a and the b. I think I have maybe one more. I have two more. I like this one. And that's it. Three more. And that's it. And then we're going to find amplitude and period from an equation, which is really easy. And I think that is probably, yes, the end of that lesson. So let's go ahead and we'll finish up these last few things. All right, here's our next one. All right, let's find the amplitude. So amplitude, the max, I'll put it on the graph actually. The max is 0.5. The min is negative 0.5. Actually, when there's no vertical translations, it's pretty easy to figure out the amplitude, but we'll do the equation. So we have 0.5 minus negative 0.5 divided by 2. That would be 0.5 plus 0.5. So that's going to be 1 divided by 2. It's 1/2. And actually, you can see it right here. So this is the amplitude. Let's see if I have enough space to write. Actually, I'll kind of try to write diagonal. Amplitude. All right, so 1/2, because amplitude goes from the middle of the graph, the midline, to the max, or the midline to the min. That distance is the amplitude. So we can see it's 1/2, and we solved it out. It really is 1/2. All right, so the period of the graph, right here. So we are going to keep this, especially on this first lesson, to the simplest equation we can write. Later on, we'll come back and we'll write this equation as a cosine graph. But you can see that our period is 2 pi. And on the last problem, we had already solved for b when the period was 2 pi. So I am fine if we just recognize that we already know that b is going to be 1, because there was no change to the period. And so our equation as a sine graph, right? So we have y equals a sine bx. You don't need to substitute 1 because that doesn't change anything, but we will substitute the a. So y equals 1/2 sine x is the equation for this graph. And you know what? If you can do these problems, it's going makes the benchmark a lot easier, because you can look at a graph and be able to find a, find b, and write the equation. All right, and then what is the amplitude and period of this graph? All right, so we have done an amplitude. We're not going to solve this amplitude out, because we have had the exact same amplitude on a previous problem. So amplitude goes from the midline to the max, or the midline to the median, to the minimum, and you can calculate it by taking maximum minus minimum divided by 2. But we've actually had the same answer before, and I think you can see from the graph here what our amplitude is. There's the amplitude shown on the graph. The amplitude is 1. So this one we won't solve out using the formula, since we've had 1 before. But we do have a change in period. So here we have several periods of the graph. You want to try, unless you're told otherwise, to start at the origin. If you were asked to write this equation as the graph of cosine, you would want to start at the first maximum. But if it is sine, you start, actually, so if you can't start at 0, 0, then, but you do have to start at an x-intercept. Hopefully, it's easier if that x-intercept is 0, 0. If you can't start at 0, 0 because the graph's been shifted, right, then you would start at the smallest x-intercept, and there's going to be a phase shift. Phase shift is just what we call a horizontal shift. Anyhow, let's go back to this problem. We're not dealing with phase shifts yet, just amplitude and period changes. So here we can see that's one cycle of the graph. So sine goes from midline to, actually let's label that to help you see. This is a good one to do it on because there's more than one period here. So we start at the midline. If the midline is the x-axis, meaning that there's been no vertical shift, it's an x-intercept. Then it goes to the max. Then it has an x-intercept. Then it goes to the min. Then it goes to the x-intercept, or midline. Maybe I should write midline. I'll put both. Midline, x-intercept. Midline, x-intercept. Go ahead and label your graph so you can see that. That here, and let's label that here. I don't think I remember to label one period on the graphs on the previous ones. Let's do that. I'll remember to do it when I teach this in class. So that is one period of the graphs. That's one typical period of sine. All right? It goes from the midline, which is the x-intercept in this case, max, midline, minimum, back to midline. Let's label, I don't know if we need to as much because the other ones only had one period on there, but maybe we should do that. Well, this has one period and a teensy bit more. So let's go ahead and label that so that's really clear as one period. So in case you forget what it looks like, you can go back and look at it in your notes. So go ahead and label that as one period. All right, and if you need to pause, go ahead and pause. Let's go back to this one and label that as one period. I mean, it's mostly one period, but it does have a little bit extra. Whoop. So that is one period. And I think we labeled the first one. Yeah, it says it on there already. So maybe that's why. The first one already had it on there, and then I forgot to label the others. So let's label it on the graph so that you can clearly see what one period looks like. So after 2 pi, there's the start of the next period, and before 0, there's the end of the previous period. But one period of this graph goes from 0 to 2 pi. One period of this graph goes from 0 to 2 pi. But one period of this graph only goes, oh, I wrote so much over that, it's hard to see, huh? Well, this was pi. So one period of this graph is just pi. So we do have a change in b. All right, so let's go ahead and solve for b. So period equals 2 pi divided by b. All right, and we'll replace period with the actual period, so it's pi. So pi equals 2 pi divided by b. We'll cross multiply. So pi b equals 2 pi. Divide both sides by pi to solve for b, and so b is 2. So the format for the equation of our graph is y equals a sine bx, and we'll replace, well, we won't replace the a because it's 1, but we'll replace the b with 2. So y equals sine 2x. So this graph only takes half as long to go through the cycle as the usual y equals sine x. It does it in just pi as opposed to 2 pi. Right? So if there's another example, if your b is greater than 1, right, it is a horizontal compression, it will take less time to go through the cycle. And here we have another one. All right, so notice that this graph goes down instead of up. All right, I think we can just use the graph to identify the amplitude and period, because these are pretty easy to figure out. Well, actually, we'll always use the graph to figure out the period. But I think we can use the graph to figure out the amplitude as well. So that represents one period. Right, so the period is 2 pi, which means b is 1. You've already established that. And we'll look from the midline to the minimum here. That is the amplitude. And you can see the amplitude is 1. So we've had this amplitude before. But there's something else happening, because this graph isn't going up first, it's going down. So this graph also has a reflection over the x-axis, which means while the amplitude is 1, A is -1. Because of the reflection, we can see that A is -1. Amplitude is always positive. We would take the absolute value of -1, which is 1. But the actual value of A is -1. So let's go ahead and write the equation. Y equals A sine bx. No change to b because it's 1, but A is -1. So y equals negative sine x. So there we've written the equation for this graph. And we'll be continuing all throughout these lessons to write equations for graphs, as well as graphing them. Last thing on this lesson, and last thing for the Nearpod, we're going to identify the amplitude and period for each graph. So the amplitude is very easy. It's the coefficient in front of sine or cosine. The amplitude is 3. To find the period, you take 2 pi and divide by b. In this problem, b is 2. So the period is 2 pi divided by 2, or just pi. Next one, the amplitude is 1/2. The period is, again, 2 pi divided by b, and b is 3, right? So b is that coefficient on x. So that means the period is 2 pi thirds, and that's it. Do not change that to a decimal. It is 2 pi thirds. We want only exact answers. It's less work for you. Just leave it as is. The amplitude is the coefficient in front of sine, so that is 2. And the period, 2 pi divided by b. b is pi. So that means the period is 2 pi divided by pi. That would be 2. Right? So it doesn't have to have a pi in there for a period. This one is 2. Right? And all of these amplitudes were positive. If any of them were negative, remember we need to take the absolute value. The last one, there's no coefficient, so that means the amplitude is 1. The period is 2 pi divided by b, and b is 4. There's actually been some easy ones. So this would be 2 pi divided by 4, or pi, I have to write this way, pi halves. We'll get into some where b is a fraction. I didn't put any fractions in here. When we have b being a fraction, it actually increases the period. So when b is between 0 and 1, we have a longer period. Actually, let's do one like that. So I'll add 1. So I'm not sure if these, I know these top 3 are in your notes. Go ahead and add these bottom 2 as well. So let's do a cosine, because we hardly have any cosines. So y equals, let's do a little bit trickier one, -2 cosine 1/2 x. Let's do that one. So the amplitude is going to be the absolute value of -2, or 2. The period is 2 pi divided by b, and b is 1/2, the coefficient on x. So that's going to be 2 pi divided by 1/2. Dividing by a fraction is the same as multiplying by the reciprocal. So this is the same as 2 pi times 2, or 4 pi. So it's going to take this graph 4 pi to get through the cycle. Okay? So that's all you have to do to find amplitude and period from a graph or equation. The top 3 are in your notes. Go ahead and add the bottom 3, and you can pause and have as much time as you want. So thanks for watching, and bye for now.